Well, hello everyone, and welcome to yet another problem from Geeks. The problem is pretty straightforward over here that we have to construct a binary tree from a parented array. So, what it is? So, we are given an array parent that is used to represent a tree. The array is 0 based indexed, and this array means that parent of I denotes that a parent node of a particular node. That means so this element parent of 1 denotes 0 is the parent. It is also said that the parent of the root node would always be -1 as there is no parent for the root, which is true. Construct the standard linked representation of a binary tree from this array representation and return the root node of the constructed tree. Cool. It is also a note for us which says, if two elements have a same parent, then the one that appears first in the array will be the left child and the one in the right is the second. You don't need to print anything and so on. We just need to return the root node. That's all it. So let's see. This is a sample example. We are presented with an array which is a parent array which says -1 for 0th element. That means 0 should be the root node. Let's check. Yes, it is. So let's jump to first element or one index element. 0 is the parent of 1. Cool. 0 is a parent of 1. 2's parent is 0. Yeah, 2's parent is 0. We see that. And we see that 0, 1, 2, 3. 3's parent is 1. Yeah, it is 1. 4's parent is 1 as well. Yeah. And based like 3 and 5. So it's 0, 1, 2, 3, 4, and it's 5. And it's 6. So it says parent of 5 is 3. Parent of 5 is 3, correct? And parent of 6 is 5. Parent of 6 is 5. So far so good. So this was how example 1 took place. So how about the example 2? The example 2 seems simple. Let's iterate it not for long and let's see 2. Yeah, the parent is 0. Sorry, my bad. Let's see example 2. So it says this is 0 index, this is 1 index, and this is 2 index. Let me rewrite this. This is 1 and this is 2. So for 0, the parent of 0 is 2. Parent of 0 is 2, makes sense. Parent of 1 is 0. Parent of 1 is 0, yes. And parent of 2 is -1, that means 2 is the root. So it's root. So this is how we have constructed the tree over here. It is said that time complexity should be O of n and space complexity also should be O of n. So let's see how it goes. Now, if at all, if it was a array of the form that said that hey, it has this left and right just in front of us, it would be so simple to go ahead and apply BFS because we know what all nodes we wanted to construct and what all the parents or the children's are. But here we only know the parent and here we do not know in advance what is the nodes. So two things we need to do over here is step 1. We need to curate all the, I hope it's visible for you. We need to curate all the nodes present out there in an array. Now, if the nodes are present, the things become simple. It's step 2. Need to assign children and parent. Once it is done, we need to figure it out root and return it. Return root. So simple it is. So without any further ado, let's get started then. So step 1, we need to curate all the nodes present in the array. Now we have all the list of nodes, but here the problem is that the value of node is being represented by the index. So this might confuse us that, hey, it is 0 index or the parent is 0. Obviously it's 0 index and it's over here. So let's assign a data structure as map, which will map for integer to node. It will store, I'm taking it as hash map. It will store the corresponding index or value. I'll say value to node, and let's take this out to a new method so that our code would be clean. I'll say it's a public node, or let's say take it private node, generate map or generate node map. Node map seems pretty good. Yeah, this is what we want. Obviously we would have integer array of parent as an input, and we'll go ahead take for each integer I is equal to 0, I is less than n, or parent I plus plus. Basically we don't even need this parent array, we just need n, and it will generate map dot put I to new node of I. Good, and we return the map. So this is how we have curated all the nodes present out there in an array. So if an array has n elements, we'll go ahead and we'll say generate node map for all those parent.length, and we'll assign this within a variable map. Let me take that here. Good. Now building the step 1 is clear. Let's head to step 2. Step 2, we are saying that we need to assign the children to parent. So we have a children and we have a parent. How do we know parent of this node? Obviously parent array says that whatever parent we have. So we have this node, the content gives us the parent. So let's start the assigning. I'll go ahead for each number within parent array, and I'll increment one by one. I'll go ahead and say node parent node is equal to map.get parent of I. It means current node, and I'll also say that current node is map.get I, and parent is this. We have current, we have parent, we just made to make a relation. So we'll say if parent node dot left is equal to null, then let's assign to left. we'll say parent node dot left is equal to current node, else parent node dot right is equal to current node. But wait a second, that it might happen that parent node of I is -1. In that case, we need to know that it is root. So if parent of I is equal to -1, then it's the root. And we need to continue, because obviously root doesn't have any parent, and going forward didn't even mean anything. So we'll continue over here, but let's not continue directly. Let's have a variable, that root index. Initially it's 0. Let's mark, you can take any arbitrary number, or you can take -69. Yeah, so I'll say root index is equal to I. So I'm playing smart over here. I'm saying not only I will iterate, go ahead and form the relationships, but also I'll find out who is the parent. Why I wanted to find out the parent? Because remember, the step 3 here is to return the root. So it would be very convenient for me within one loop itself. I'm not only forming the relationships, but also getting the root index. Now, till the moment this for loop ends, we now here have each and every relationship out there. Now let's jump to step 3, that is return root. We just need to return root, and nodes are being stored by this map. I'll just access the map to get the root index. And yeah, pretty much straightforward. Let's compile this to check for any compilation issues or anything as such. It seems there is one compilation issue. Okay, we need to return this, not node. Okay. And the rest is, we don't need to return map. Yeah, no, that's a part of this. Cool. Let's check for any other compilation errors. No, there is none. So cool, it passed for the sample test case. Let's check for the rest of the test cases as well. Yeah, it seems that our code has passed all the test cases over here. And yeah, so the problem was pretty simple. We have made n1 iteration to get all the nodes, to generate all the nodes, and to generate the mappings. You can play smart over here, you can generate on the fly. However, I won't recommend that. That would be something like, you'll go ahead and say map get or default, and you will put a gain within the map. That would solve it within only one for loop. It's a nice exercise for you to go ahead and do it, but it will make our code ugly. So yeah, we have achieved this feat with O of n time complexity and O of n space complexity. That's all for now, and if you find this video interesting, check out the video on your right, and I'll see you in the next one.
Let's step in, I'm haunted, and if I'm being honest, I see what he loves about you.